Hi, in this video I'm looking at performing this integral here, 9 tan squared of x dx. So tan squared is a little bit tricky to integrate, but not if we can convert it into something else that is easier to integrate. And we're going to use one of the results of the Pythagorean identities. So the main Pythagorean trigonometric identity is sine squared plus cos squared equals 1. But if you play around with the properties of sine squared, cos squared, secant, tan, you can get the trigonometric identity that says that tan squared of a value plus 1 is secant squared of that value. So we can use this to turn our tan squared into something in terms of secant squared. And this is useful to us because the integral of secant squared of x dx is just tan of x plus c. So if we can rearrange this to get into terms of secant squared, it's an easy integration. And we do that simply by turning tan squared of a and minus 1 off of both sides, and we get secant squared of a minus 1. So we can use this now and replace the tan squared with secant squared minus 1. So if we go and do that, that's going to give us the integral of 9 outside of the tan squared of x is going to change into secant squared of x minus 1. And we're still with respect to x. So now I'm going to tidy this up a little bit by taking this 9 outside the integral because it's a constant. So that's going to leave us with 9 times the integral of secant squared of x minus 1 dx. So now we can perform this integral. So I'm going to have 9 times the result of my integration. And we're going to start off with our secant squared of x because it's going to turn into tan x. So secant squared becomes tan x. And the minus 1, well, the integral of 1 is just x. So we have 9 times tan x minus x plus c. And then multiplying that 9 in, we get 9 tan x minus 9x plus c. And so that is the result of our integral of 9 tan squared x dx. And we got there by using a trigonometric identity that tan squared plus 1 is secant squared. And the integral of secant squared is tan.